Hello grade 11, welcome. In this video, let's talk about metamorphism. Tara!
Our discussion will focus on the learning competency, describe the physical and chemical changes in rocks due to changes in pressure and temperature. At the end of the lesson, you should be able to 1. Define metamorphism, and 2. Describe the physical and chemical changes in rocks due to changes in pressure and temperature. Rocks are solid materials that comprise most of Earth. They are formed in Earth as igneous, sedimentary, or metamorphic. Have you ever wondered how these rocks formed or changed from one type to another? Inside the Earth, new type of rock is being formed from other type of rock in the process called metamorphism, which comes from ancient Greek words meta for change and morph for form. Metamorphism refers to the isochemical process by which rocks are changed by heat and pressure or some chemically active fluids. The chemical composition of the parent rock will be the same as the metamorphic rock produced. During metamorphism, rocks change because the minerals need to be stable under the new temperature and pressure conditions. Pressure refers to the measure of the stress or physical force applied to the surface of a material. Pressure steadily increases with depth. The higher the pressure, the greater the degree of metamorphism. Pressure is applied to rocks in three different ways. The pressure applied by fluids trapped in sediments or grains of porous rock is called pore pressure. The presence of water speeds up reaction by acting as a catalyst in increasing the rate of ion exchange. This usually happens in subduction zones. Load pressure refers to the weight of overlying rocks that physically brings minerals into contact with each other over very long periods of time. When rocks undergo folding or faulting due to very high pressures exerted over relatively short periods of time, this type of pressure is called tectonic pressure. Temperature is also a factor of metamorphism. As temperature increases, the rate of metamorphic reactions also increases. Temperature also increases with depth due to geothermal gradient. If rocks are buried within the earth, the deeper the rock gets, the higher the temperature it experiences. Chemically active fluids, that is mostly water with dissolved ions, also affects metamorphism. It exists in open space between mineral grains in a rock. The fluid phase is essential because chemical reactions that involve altering a solid mineral into a new solid mineral can be greatly speeded up by having dissolved ions transported by the fluid. This usually occurs in subduction zones. Grade of metamorphism. Metamorphic grade is a general term for describing the relative temperature and pressure conditions under which metamorphic rocks form. As the temperature and pressure increases on a body of rock, then grade metamorphism increases. Let's have first the low-grade metamorphism. This takes place at temperatures between 200 to 320 degrees Celsius and relatively low pressure. Examples are clay minerals, serpentine, and chlorite. These are characterized by an abundance of hydrous minerals. Next is the medium-grade metamorphism. Takes place at approximately 320 to 450 degrees Celsius and at moderate pressures. Examples: muscovite, biotite, and garnet. High-grade metamorphism takes place at temperatures above 450 degrees Celsius. Examples are the non-hydrous, magmatite, and pyroxene. This picture shows how rocks change due to changes in pressure and temperature in low and high-grade metamorphism. Shale becomes slate, granodiorite becomes folded gneiss. There are two types of rock textures, the foliated and the non-foliated metamorphic rocks. Foliated metamorphic rocks have a layered or banded appearance that is produced by exposure to heat and direct pressure. Foliated rocks are formed if the pressure applied to the recrystallizing rock is unequal. The force on the reforming rock must be strong and one-directional. The randomly oriented minerals in sedimentary rocks are subjected to pressure and aligned, creating banded or layered appearance of the rocks. Foliated rocks are most often formed from mudstones and contain fine-grained or platy minerals that are usually too small to see with the naked eye, although some can be seen without aid. Examples of foliated rocks are the following. As you can see, the mineral flakes will appear to be parallel to the rock and will look layered. When a foliated rock breaks, a thin rock fragment will result. Non-foliated metamorphic rocks, however, have no evident planar fabric or foliation, crystallized under conditions where there were no differential stress, and are comprised of minerals. These are created if the pressure applied to the recrystallizing rock is equal all over. Here are some examples of non-foliated rocks. If minerals can foliate but haven't, the rock was not subjected to directed pressure. This usually occurs in contact metamorphism. The minerals in non-foliated rock will appear to be randomly oriented without obvious banding and have a granular appearance. Unlike a foliated rock, there will be no layers and they will not flake apart into thin layers when broken. Non-foliated rocks contain more coarse-grained minerals and generally have a random shape. Because of this, these rocks are very granular in appearance. Examples of non-foliated rocks are quartzite marble and anthracite coke. There are two types of metamorphism, the regional metamorphism and the contact metamorphism. Now let's start with regional metamorphism. These are caused by large geologic processes such as mountain building. This is commonly associated with convergent plate boundaries and the formation of mountain ranges. Regional metamorphism usually produces foliated rocks such as gneiss and schist. Contact metamorphism occurs when magma comes in contact with an already existing body of rock. When this happens, the existing rock's temperature rises and also becomes penetrated with fluid from the magma. The area affected by the contact of magma is usually small, from 1 to 10 kilometers. Contact metamorphism produces non-foliated rocks such as marble, quartzite, and hornfels. And that ends our lesson. Congratulations!
Kick.